Because you learn how to think analytically and to solve problems rigorously. And these are qualities highly valued by industry, and they're useful pretty much anywhere else in life. Because it still opens doors for most of the careers you can think of. Because it prepares you to tackle the most essential problems of our era, such as clean energy, climate change, sustainable resources, and fair and ethical data-driven technologies.
Because physics is an endlessly fascinating and extremely collaborative effort to answer one of the most profound questions humanity's been asking for millennia, which is, how does everything around us work?
Academia, research labs like CERN, medical applications, artificial intelligence, industry, banks, metrology, scientific journalism, education, the list goes on. Because of the variety of topics offered, covering all the main research lines, so for my department this means particle physics, astrophysics and cosmology. Because of the unique proximity to CERN,
because you'll get a chance to work with some of the most renowned international researchers and their research groups on cutting-edge projects, because you'll be part of international collaborations and will be able to do some of your coursework or your master's research either at universities abroad or in collaboration with institutions like CERN, the Paul Scherrer Institute or the ICPP.
Because of the international environment in Geneva, because after all, Geneva is a student city. The formula is simple but very efficient. In the first year, you take advanced courses, so you become some sort of an expert in a certain domain. In the second year, you apply this expertise to real-world science problems at the forefront of physics, and you do this within a research group here at the University of Geneva, working together with PhD students, with postdocs, integrated in international collaborations such as the Atlas experiment at CERN. What you need to bring is motivation, curiosity, an open mind, and the willingness to invest yourself fully.
For me, a master's in physics is the first time you embark on your journey really as an individual scientist. During that year of research, there will be a moment when you will find something in your data that makes you realize you are the first person seeing it. For me, it's looking at the conduction of ferroelectric domain walls and knowing that I am the explorer who sees this for the first time and can bring it to other people.
So for me, it has always been about a scientific method and how far we've gotten with such a seemingly simple concept. So how does it work? You observe nature, you try to come up with theories to describe it, you make hypotheses, you conceive, design, build experiments to test these hypotheses and, if necessary, devise the theory. With this approach, we have managed to describe the smallest scales of the quantum world all the way to the biggest scales of the universe. We built machines such as the Large Hadron Collider at CERN, the largest project ever devised by mankind, where thousands of scientists work together in a truly international way and sharing a common vision. On the way of doing these experiments, we built the most amazing tools such as high-tech instrumentation, detectors, computing, analysis, statistical tools. And most of the time, these tools prove to be useful not only for physics, but also in our lives, such as the World Wide Web or GPS. One of the most recent tools I'm particularly excited about is machine learning, which has an enormous potential to transform the way we do physics and transform all our lives everywhere in all aspects. So if I were given again the chance today to choose a master project, I would pick it at the intersection of physics and computer science, and this you can do here at the University of Geneva.